You shift it when.
Yeah, what I was saying here is, with the theorem that says, if to take the Laplace transform of this, right, you'd have to shift it by an amount. The theorem says you can shift it by an amount A. Nonetheless, f of s will still be the Laplace of the original function f of t.
Right.
So in this case, f of t, in our case, is just the absolute value of t to the minus 5.
Yeah.
Which we already gone through all this process to take the Laplace transform for. This was the question before this one.
Yeah. And then you
so
you fill in for s minus.
Yeah, so this turned out to be that, and now the theorem tells me if a is 3, because it's e to the 3t, the theorem tells me you take the Laplace of that original one, absolute value of t minus 5, and you replace every s with s minus 3,
right,
because it's f of s minus a. So I went to every place on this one where there's an s, and I replaced it with s minus 3, so this became s minus 3, and then 5s minus 1, this is 5 times s minus 3 becomes 5s minus 15 minus 1 becomes minus 16 plus 2 divided by s plus 3 squared e to the 5s minus 3.
Right.
So this would allow you to shift it by an amount of 3, because it's e to the 3t.
Right.
So if you get here and you want to see, you can always go back to the previous question, and I've recorded this and I have the notes, where you could see all the steps for the Laplace of the absolute value of t minus 5. Then this question becomes super easy. It becomes one step of just replacing s in the Laplace of the absolute value of t minus 5. You just replace the s with s minus 3, and you get the Laplace of e to the 3t, the absolute value of t minus 5. Okay?
All right, yeah.
Which comes out to be this.
Okay.
Any questions on that? Okay, so this, we did both of these using the definition, and then the definition of Laplace for the inverse of for the absolute value of t minus 5. Then we followed that with one of the properties of Laplace, which would allow us to shift it.
Right.